We're going to start another type of pattern. Notice in this pattern, we've got x squared plus bx plus c. What you need to note is that the coefficient on x squared is 1. Okay, so this one is still pretty friendly. And notice also that we've got three terms. So it says if x squared plus bx plus c, where b and c are integers, is factorable, it can be factored as the product of two binomials of the form x plus m times x plus n, where m and n are integers. Okay, doesn't really tell us how yet, but it does say that it can happen. All right, so then in this example, we want to factor x squared plus 15x plus 56. Okay, step one. If we have any common factors, factor them out. Okay, we don't. So we don't have to do that first step for this example. Okay, then it says find the factors of the constant term. Okay, so we can make a list of all of the factors of 56. Okay, 1 and 56. 2 and what else? Uh, 28. Okay, 3. Is 3 a factor? No, 3 is not a factor. Is 4 a factor?
14.
Okay, 4 and 14. All right, we can go 5's not a factor. 6 is
7.
not a factor. 7 and 8. Okay, very good. All right, so we made a list. All right, then it says select the factors that add up to the middle term. Okay, so which pair of factors that we've made in this list add up to 15? 7 and 8. Okay, and so it says rewrite the polynomial in its factored form as x plus m times x plus n, where m and n are the numbers found in step 3. So we can write this as x plus 7 times x plus 8. Okay. We can check it out by multiplying it. When we multiply this together, it should take us back to where we started. So if we use FOIL, we get x squared for the first, for the outer plus 8x, for the inner plus 7x, and for the last plus 56. So we get x squared plus 15x plus 56. So we know that our answer is correct.
When you do just a list of the ones, was it just out of the 56?
Just the 56. That's all we
Take
looked
the
at.
last term and you just factor that one out.
That's right.
Okay.
So
Simple, right?
in the form that we're looking at, it doesn't have a variable. Okay, so looking back at x squared plus bx plus c, notice here c is just a constant. So that's the particular form that we're talking about right now. And we force, by looking at the factors of that constant term, we force it so that when we multiply those last in the two binomials, they're going to come up to 56. Okay, so the only other thing we need to think about is when we do that inner and outer, will it add up to 15x? That's why we picked from this list things that we already know are factors of 56. Now we need the two that are going to add up to 15x. So that's kind of why it works. All right. Now, lots of sub cases here. What we looked at in the first example, we had C was positive. Okay. Also, B was positive. So in this case, we're going to do plus M plus N. Okay. Both of them will be plus. So I'm going to look at this example. I need to think about the factors of 13. What are the factors of 13? Okay, 1 and 13. Those are the only two. And we need them to add up to what? 14. 1 plus 13 is 14. So this is going to factor as x plus 1 times x plus 13. Okay. Notice that my product is positive, so I get that. And then my sum is positive. Plus 1x plus 13x, we get that. No, FOIL was just our check. We just use FOIL to check it. What we want to do is factor it, so it means to write it as a product. Okay. All right, try B real quickly on your own. Okay, how many people got x plus 9 times x plus 9? Okay, or you could write it as x plus 9 squared. Again, our constant term is positive, the middle term is positive, so each of these will be positive. All right, but in this case, we can see that the constant is positive, but the middle term is negative. So when we do m and n, they're going to be what? Negative. Okay, a negative times a negative will give us a positive, and then when we add the two negatives, it'll still be negative. So I'm going to look at factors of 54, but they both need to be negative. So negative 1, negative 54. Okay, negative 2, negative 26. Okay, negative 3, negative what? 18. Okay, what else? Negative 6, negative 9. Is that it? Yeah, okay, this is it. All right, once we find the pair that adds up to the coefficient in the middle, then we can stop. We don't have to keep going. So I'm going to write this as x minus 6 times x minus 9. All right. Okay, what about D? Okay, 10 and 3, so we can write this as x minus 10 and x minus 3. Okay, negative 10 times negative 3 gives us positive 30. Negative 10x plus negative 3x gives us negative 13x. No, the order that we multiply in does not matter. Okay, questions? Yeah. The first time you try something, it'll be a little difficult. Okay, I got E and F for you to try on your own. Okay, did you get x minus 12 squared for E? Okay, and then over here, I would do negative 5 and negative 6. They will add up to negative 11, so we get x minus 5 times x minus 6. Okay, questions about that? Okay, if we're factoring x squared plus bx plus c and c is negative, then m and n have to have opposite signs. Okay, and the one with the larger absolute value will have the same sign as this middle term. Okay, so let's say we're looking at x squared plus 5x minus 14. Okay, we could do 1 and 14, where of course one of them has to be positive, one has to be negative, 2 and 7. Okay, looks like we could get it with maybe 2 and 7. Okay, 7 has the larger absolute value, so it's going to have the same sign as 5x. Okay, so we're going to say x plus 7 times x minus 2. Okay, that way in the middle we get plus 7x minus 2x. We get positive 5x. Questions about that? All right, when I look at H, I can tell that M and N have to have opposite signs because of this negative 39. So we could be looking at 1 and 39. What else? Okay. Okay, 13, 3. Okay, that looks like it's going to work. Our middle term is negative, so we're going to have what? X minus 13, x plus 3. Okay. Questions about that? All right, try I and j. Okay, for I, we've got a negative 12 as our constant. So I'm going to use x minus 6, x plus 2. Okay, minus 6x plus 2x gives me minus 4x. Okay, for j, we've got a negative 24. So what did you use? Very good. All right, x minus 8 times x plus 3. All right. Then for k, we've got a negative 64. So what did you use for that one? No, it has to be x minus 8 because we have minus 5x in the middle. All right, over here for negative 64, you got what? Okay, x plus 16, okay, times x minus 4. Okay. And remember, Elliot, back to this one, we said the larger absolute value, so that's 8. 8 has larger absolute value than 3, will match this sign.
So wherever the largest, like the largest number already takes place of the
It's going to take the same sign as the middle term. Like here, okay, we had a positive middle term. 16 is larger than 4, so 16 is positive. All right. Okay, for L, what'd you get? Okay, x plus 10, x minus 3. Okay, so plus 10x minus 3x gives us positive 7x. Questions about that? Okay, very good. All right, factor a perfect square trinomial. Okay, this is one of our first patterns, but we were just talking about this, I feel like maybe yesterday or the day before. Okay, if we have a squared plus 2ab plus b squared. So what do we need to note about this particular pattern? It starts with what? A squared, a perfect squared. It starts with a perfect square here. Then we have perfect square on the end. And in the middle, we've got 2 times a times b. Okay, well, that's going to factor as, anybody want to take a guess? A plus b squared. Okay, we just learned the pattern for multiplying this, right? We said a plus b squared multiplies out as a squared plus 2ab plus b squared. So now we're going in the opposite direction. When we factor it, we get a plus b squared. All right, so if we can recognize that we've got a perfect square for our first term and a perfect square for our last term, and then just do a check on that middle term. Is it 2 times a times b? Then we can use this pattern. Okay, here's an example. We've got 3x squared plus 60x plus 300. Our first step should always be what? Factor out the greatest common factor. In this case, that's going to be 3. Okay, so if we factor out 3, we're left with x squared plus 20x plus 100. Okay, so now I'm going to look to see if I've got some perfect squares. Okay, we've got a perfect square for my first term. It's what? Obviously x squared. What about that last term? It's 10 squared. So for me, a is x, b is 10. In the middle, do I have 2 times x times 10? You said yes or no? Yes, right? So this fits the pattern of a squared plus 2ab plus b squared. And so we know that factors as just a plus b.
where's the two?
That's part of the pattern.
Oh yeah,
But
yeah.
what I identified was what my a was here, which is x, and my b is 10, And so if I do 2 times A times B, it comes up to 20x. So yes, it fits the pattern. Okay. All right. So now that you recognize the perfect square trinomial pattern, write out or recall the appropriate factoring. And so it is just x plus 10 squared. All right. Oh, I got so excited I forgot about him. He just comes on down. Please don't leave him off. Okay. The 3 is still there. All right. We bring down whatever the greatest common factor is. Okay. All righty. Now, before we look at this next one, it may be useful for us to make a list of perfect square numbers. So if, let's say, x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we should probably be familiar with at least these. And then x squared, okay, 1 squared is what? 1, 2 squared is, okay, 49, 64, y'all slowing down, 81, 100, 121, and 144. Okay? Yeah, you say you know it. And the squares are a little more familiar. We'll add to this when we talk about perfect cubes. Well, why don't we go ahead and do it now since we got it up here. Okay? All right, so 1 cubed is what? 1, 2 cubed, okay, 3 cubed, 4 cubed, 64, very good. 5 cubed, okay, is 125. 5 times 5 is 25 times 5 is 125. 6 cubed, 216. 7 cubed, 343. 8 cubed, 512. We'll stop there. Okay, not to say that it won't go beyond that, but when you see these numbers, it should kind of trigger something. So be familiar with the perfect squares and the perfect cubes. All right. Okay, so going back then, we were looking at factoring 9x squared minus 42x plus 49. Okay. First, we look for common factors. Do we have any? No, we don't have any common factors. Okay. Then we check to see if we have any perfect squares on the beginning and end. Do we? Yes. Okay. 9x squared we could think of as 3x, very good, squared. And then 49 is 7 squared. In the middle, I forgot to tell us about our second pattern, but in the middle, do we have 2 times 3x times 7? Yes, right? That's 42x. So this fits the pattern. What's different from the first one is what? The sign. The middle term is minus. So in the middle, if that middle term is minus, we got a perfect square at the beginning, perfect square at the end. We got 2ab in the center, but it's minus. This factors as a minus b squared. Okay. So if that's the case, now that we've identified a for us is 3x and our b is 7, and then we had a minus in the middle, then this is going to factor as what? 3x minus 7 squared. Okay. All right, questions about that? All right, very good. If we can recognize that pattern, then it'll save us some time in our factoring. Okay? So try these two on your own. Okay? Did you get these answers? All right. Very good. Okay? Very good. Let me give you one more because those were both kind of easy. Um, what about, all right, what'd you get? 9x minus 8 squared. Okay? This is a perfect square. It's 9x squared. 64 is a perfect square. It's 8 squared. Okay? So 9x times 8 is 72 times 2 was 144.
So
Yes.
question for you. The first one we did, we actually pulled the 3 out on the outside.
Yes.
What was the difference? Because I'm looking at it and we pulled a 3x squared out of there.
Which for this problem right here,
The very first one we did was 3x squared plus
we
64.
had common factors. So our first step should always be to look for any common factors. Okay, but in this one, we don't have any common factors. Okay? All right, other questions? Okay. Trinomials that are prime. Okay, because sometimes, guess what? They won't factor. So how do we know? If there are no factors of C that add up to B, then we say, that should say, that the polynomial is prime. All right? So we're still talking about ax squared plus bx, or I'm sorry, just x squared plus bx plus c, where leading coefficient is 1. The only time it's been different from 1 so far is if we had a special pattern or if we could factor out greatest common factor and then get it to 1. All right? But when I look at this one, if my leading coefficient is 1, then I look at the constant term. I think about all of its factors, every pair, 1 and 15. What else? 3 and 5. That's it, right? And neither one of these pairs adds up to 7x. So we say that it is prime. Just like the number 5 is prime. It only has itself and 1 as factors. So we say it's prime. Okay? All right, over here we've got x squared minus 11x minus 28. So we can look at 1 and 28. Okay, 2 and 14. What else? 7 and 4, or 4 and 7. Okay, that's pretty much it. So when we look at these, letting one be negative, one be positive, we know that because of the negative 28. Then when we add those up, do any of them add up to negative 11x? No. Okay, so if we've checked carefully, then we say prime. Okay, questions about that? Well, 7 and 4, one, remember, one has to be positive, one has to be negative. So if it's positive 7 and negative 4, that's going to give us 3. If it's negative 7 and positive 4, that gives us negative 3. So it doesn't work. Okay? All right, other questions? Okay. Factoring a trinomial whose terms have a common factor. We always, always, always want to try to factor out greatest common factor first. So when I look at A, what do they have in common? 4. So I can factor out 4. I'm left with x squared minus 7x minus what? 18. Okay, very good. All right, now I've got this trinomial where the leading coefficient is 1. So what do I do? Look at the constant term. Look for those factors that add up to the middle term. They're going to be what? Okay, 9 and 2. Which one's going to be negative? Okay, so x minus 9, x plus 2, and we're done. Okay. In B, first thing we're going to do is look for common factors. If you forget to look for common factors, sometimes you can still factor it, but it may be a little more difficult. And often what the instructions will say will be to factor completely. So we want to break it down until you can't break it down anymore. And sometimes you'll forget to take out that common factor if you don't do it first. So in B, what do we have in common? Okay, we can factor out x squared or even what? Negative x squared. I'm going to take out negative x squared. I'm left with x squared what, minus x minus 30. Okay, I like to have a positive 1 right here. That's why I took out that negative x that was on my leading term. Okay, now that I have this positive 1, then we get, and we got a constant here of negative 30. So we're going to have what? Okay, x minus 6, x plus 5. Very good. Okay, questions about that? But you can save yourself a lot of trouble. Yes, it's a lot of big numbers. You can save yourself some trouble if you do what? Factor out the greatest common factor first. Don't forget to do that. All right? So try C and D. Okay? So we factored out 2x for this one. And now we're looking at factors of 98 that add up to negative 21. I know they're both going to be negative. Since this thing is positive and this one is negative, so it's what? Y'all didn't find anything? Okay, negative 14 and okay, minus 7. Okay, very good. All right, does everybody agree? Okay. How many people got that? Okay. You got to persevere. Okay. So when it comes down to breaking down 98, still pretty large. Sometimes it's helpful to do the prime factorization. Let's see if we can do it that way. And if this works, great. If not, then don't worry about it. But we got, okay, 2 and what? 98 is equal to 2 times 49, right? Okay, so we're talking about 2 times 7 squared. So that kind of helps me to see what the possible factors could be, just pairing different of the prime factors together. We've got 2 times 49. Okay, if I take one of those 7s and put it with the 2, it's going to be 7 times 14. Everybody see? You know, and then if there were some other ways I could pair things, then that would give them. But I think that's about it. That's as far as we can go. Now that we've done that, we know that these multiply out to give us 98, which 2 will add up to 21, 7 and 14.
No question. Could you just take the middle number right there and find out actually what adds up to that, and then see if that's going to be because it's got to add up to it regardless, and then see the
True,
factors of the
but
98.
you'd probably have more things that would add up to it. than the factors. Like, I mean, it'd be 1 and 21, 2 and 19, 3 and, 18. That would be a much longer list. Okay. In most cases. All right. And even if the difference was, let's say just one, there's still infinitely many things that can add up to, one, if one is positive and one is negative. Okay. All right. For D, okay, we got 9x squared plus 126x plus 432. Okay, I'm kind of hoping that 9 is a factor of 432 and 126, is it? Okay, so we can factor out 9, and we get x squared plus what? Okay, 14x plus 28? 48, okay? All right, well, once we do that, that doesn't look so bad, right? We can think about the factors of 48 that add up to 14. That would be what? 6 and 8. So this is just 9 times x plus 6 times x plus 8. Okay. All right, so factoring trinomials in several variables. So far, we've only had trinomials, or any of the polynomials we've looked at today have only had one variable, okay? But what happens if we have two variables? For instance, we've got x squared plus 11x plus 28 here. Over here, we have x squared plus 11xy plus 28y squared. Well, it still pretty much factors the same way, okay? Except now we need to, when we look at the factors of this last term, there's going to be a y involved, right? But we still need the coefficient in the middle to add up to 11. So over here, if I wanted to factor x squared plus 11x plus 28, that factors is what? Okay, x plus 7, x plus 4. Okay, 7 times 4 is 28. But over here, when I factor, I don't need just 28, I need 28y squared. So it's going to factor as what? Very good. Very good. So pretty much the same thing. Now we can see 7y times 4y gives me 28y squared. And if I multiply my inner, that gives me 7xy. My outer gives me 4xy. 7 plus 4 is 11. Okay. All right, so for A here, let's do this one together. Just kind of looking at the x squared, the 6x to 27. If you need to look at it that way, we can factor that as what? Okay, let's look at it a different way then. Okay, 9 and 3. All right, so 9 times, positive 9 times negative 3 gives me negative 27. And then 9 and 3, positive 9, negative 3 will give me 6. So we're going to say x plus 9y times x minus 3y. Okay. Okay, what about here? We've got a squared plus 15ab plus 36b squared. Okay, 12 and 3. All right, so we've got a plus 12b and a plus 3b. 12 times 3 gives me 36. Okay, and then 12ab plus 3ab will give me 15ab. Questions about that? What about C? Okay, 12 and negative 12? Okay, very good. This fits one of our patterns, right? We've got a perfect square here. It's x squared. And then here, this is 12y squared. And in the middle, we've got 2 times x times 12y. So this factors as x minus 12y squared. Okay. You still could have, just kind of tried the pairs. That works as well. But in this one, we had our pattern. Okay. What about in D? First, we have to do what? Factor out a 3. So we've got 3. We're left with x squared minus 12xy minus what? What was it? 28y squared. Okay. And so now I'm looking for factors of negative 28 that add up to negative 12. We get x 14y and then x plus 2y. Okay, when we check it, multiply negative 14y, positive 2y is negative 28y squared. Okay, and then negative 14xy plus 2xy, we get negative 12xy. Okay, questions about any of that?